Please ಕಡೆ ತಿರುಗಾಡಿ ಮಾತಾಡ್ತಾರಾ
ಹೌದು
ಸರ್ ಕಾಲರ್ ಸೆಟ್
ಸರ್ ಯು ವಾಂಟ್ ಕಲರ್ ಮೈಕ್ ಸರ್
ಕಾಲರ್ ಮೈಕ್ ಅಲ್ಲ ಸರ್ ಯೂಟ್ಯೂಬ್ ಮೈಕು
ಯೂಟ್ಯೂಬ್ ಮೈಕಾ
ಹಾಂ ಸೆಟ್ ಮಾಡ್ಕೊಳ್ಳೇಬೇಕು ನಾವು
ಯಾಕೆ
ಯೂಟ್ಯೂಬ್ ಲೈವ್ ನಡೀತಾ ಇದಲ್ಲ ಸರ್
ಹಾಂ
ಸರಿ
ಯೂಟ್ಯೂಬ್ಗೆ ಒಂದು ಮೈಕ್ ತಂದ
ನನ್ನ ಕ್ಯಾಮ್ರಾಗೆ ಒಂದು ಮೈಕ್ ಇದೆ ಸರ್
ಹಾಂ
ಅದಕ್ಕೆ ಸರ್ ಆ ಸ್ಪೀಕರ್ಸು ಇಟ್ಕೊಂಡು ನಾನು ಮಾತಾಡ್ತೀನಿ ಕೇಳಿಸ್ತಾ ಇಲ್ಲ ಹೇಳಿ ನಾನು ಹಿಂಗೆ ಇಟ್ಕೊಳ್ಳಿ ಸರ್
This is a caller mic, right?
ನೋ ಸರ್ ದಿಸ್ ಈಸ್ ಎ
ಯೂಟ್ಯೂಬ್ ಮೈಕ್ ಯೂಟ್ಯೂಬ್ ಲೈವ್ ಸರ್
ಓಕೆನಾ ಸರ್
Okay. Caller mic I don't require. I'll be mostly here because then I understand. There will be a lot of feedback. So many mics means there is a feedback.
ಓಕೆ ಸರ್ yesterday I have given mic na sir that is the two problem sir
No, actually multiple mic always creates feedback.
ಅವಾಯ್ಡ್ ಮಾಡ್ಬೇಕಂದ್ರೆ
Yeah. I will also take help of your pointer.
point only left and right
That
no it will not go in it will sink into the screen
okay. Then I will use that.
Good morning, all. Dear students, participants, dear students. So let us start. Are you all okay? Are you comfortable now? Shall we start? Okay, guys, kindly sit down. Chaudhary ji, Priya, sit down, all of you. Chaudhary ji, stand up. Hello.
Caller mic, it will not be so audible. This now,
No, this is
should
very
speak
good.
in front.
Right.
Earlier it was back.
Right.
So whenever you're speaking, you should
Right.
speak in front of.
Exactly. Actually, caller mic will create a feedback. It is unnecessarily caller mic is creating making a feedback.
For the second day workshop, top resource of the world. Yesterday, Dr. Rajkumar BS sir has already given an Aneka demonstration and cloud platform using Amazon. So today we have two dignitaries. One is Dr. Soumya Kanti Ghosh sir, who came all the way from IIT Kharagpur, West Bengal, for giving a wonderful session on latest technology with respect to the cloud and data technologies. So I take this opportunity to welcome you, sir.
Thank you.
Today, first session resource is Soumya Kanti Ghosh sir, and second session, after the sir session, there will be another session by Dr. Satish Sriram sir from University of Hyderabad, and who served in foreign university and other stuff. So I request from you to be attentive and take a complete utilization of the session. Do not discuss among yourselves.
Slide mover.
Okay. So you require that.
Maintain
That
the
side, USB is
minute of
there.
silence and attend the session. If you have any doubt, feel free to ask. Okay. I take this opportunity to welcome.
But
Satish
pointer may not
Sriram
work,
sir
right?
And Dr. Rajkumar BS sir and all
The pointer may not work.
from
I think yes, it
different
will work.
sources and our
Now this will work.
and all the SIET staff.
And this is pointer.
But pointer is what is happening, it is getting absorbed. Here it is okay. It is getting.
White color it will
Yeah, right.
So it will help
For
it,
the
right? It will work.
upcoming session.
Thank you.
Come.
Thank you. Thank you, Professor Dinesa, for a wonderful intro. It's great to be here. So we'll start the session. It will be around 1 hour, I think. Yeah. It will be around 1 hour. If you, yeah.
Speaking, it should be.
Okay, okay. All of you can hear me, right? Okay. Very good. Okay. So, due to different sound and other things, so I request all of you to keep quiet. Check that your phone should not ring in between. That will unnecessarily disturb. Right. If you have a query, raise hand. Will be interactive more of the things, right? So it was a very nice sessions yesterday with a splendid introduction from Professor Raj. So we will continue. I will go little means what we say a emerging or a very well researched topic, and which become very relevant with the cloud, fog, edge, containerization, microservices. So initially we'll start with something called spatial data, and then we'll go that how this is useful for linking and why we are discussing all these things, right? So any idea what is spatial data? Anybody? So a data which is seen from the space is spatial, right? So if I fly a so-called drone over it and have this auditorium, or inside the auditorium a map like who is sitting where, which color of chairs are at where, so there is a spatial context, right? If we fly the drone above, then we can see where is SIET, what are the different departments. You go little up on the things, then the SIET may look as a point. If you go come down, it requires a something called polygon type of thing, right? So in other sense, all data sets which can be seen above, from above something, can be as a spatial. So what is the speciality of this data? One is it has all the property what a data set have, right? Along with that, it has a thing called coordinate system, like where it is location and sometimes where it is located, right? So today if I take the picture of this, we see that number of participants, where, how the distribution, who are sitting where. But if tomorrow after the conference nothing is there, if they take the picture of the same drone flying over this, then we may find that those are blank chairs, right? So that means where and how, where and what is there. So space and time is becoming an important aspects for many of our activities, right? We are well used to the navigation systems, right. If you want to go from here to Bangalore or some other place, we usually use different mapping service, Google Map, Bing Map and type of things. So, that also have a special context, right. Now, the property of this sort of a data is pretty large, hugely large. I will give you an example, say if we see with our own satellite system like IRS category of satellite of ISRO. So, if we take a picture of this Tumkur, it may not come in a one snap, it may come in 3-4 snaps. So, the size of the data is some square 5000 cross 7000 into 8 layers, right. So, enormous. With our all general thinking, if I have this sort of a matrix, doing anything meaningful is very difficult, right. So, this sort of a data is truly what we say big data, right, and it requires special type of attention, and with the advent of cloud etc., it may be a good to look at, right. So, what I will do initially will give a overview of what the spatial data is there, and then we will come back to how to link it with this cloud and fog and type of architecture, and then we will see some of the applications if time permits, right. So, if you see say our mother earth, even if your this institute, what we have, we are having this the last thing, right. It is the this thing, right. So, there are some build up, there is some road, there may be some water body and type of things, right. But if we take out all those things, like if I only look at the road network or only look at that how what are the different things are there, this department, that department, right. So, it is different layers. In other sense, if I tell you given a picture that you find out the road, draw on a transparency sheet of say A4 side of a picture of this SIET, then you draw the road. If I say draw the buildings, you will draw the buildings, like picture is at the back, so you make the things. And if I say that you draw some of the points like where is the bank, ATM, where is the say a particular say post office etc., if they are inside the thing. So, you draw those things, right. So, we typically see we deal with 3 type of features, either it is a point or a line or polyline or a polygon, right, a area which is there, right. So, in other sense we can have this sort of a things with multiple layers. In reality also, if you see any country, in our country also, there are several department, government department or federal agencies or departments who collect data for their purpose, like Survey of India do survey, geological survey do geological related, soil survey do soil type of data, right. Transport authority have that transport network. So, they take the data for their purpose. Now, if I want to use suppose the data for my purpose, like I want to find out what is the say what is the nearest food court or nearest say McDonald or KFC in Bangalore in somewhere, then I need to now punch this, make this data sit together, right. So, this data again I am telling it is a huge volume of data, right. So, like petabytes of data is maybe a small thing which ISRO collect every day, right. So, handling running a simple SQL query on this data is enormous task. So, need to be having a different type of aspects. So, what we have, so it can be satellite remote sensing which satellite data collect, there is a weather and climate data, there are census data which different type of sensors, and also if we extend even we can think of any spatial, like also medical data is considered as spatial data, like if I take a scan of my body, so there are where the organs are there and etc., etc. But as of now we are not considering this medical type of things, right. As of now we are more concerned about the real art type of applications. So, what are the applications? There are different applications, like look at, like yesterday we are talking about smart transportation, smart cities, smart agriculture. Everywhere what you do before this smartness come into picture is that data need to be there, right. If your data is not appropriately in place, then you cannot do this all things, right. So, there are several type of applications, right. So, these are geometric and varied. So, there are geometry property, they are naturally high dimension, like see this, even if you consider this down the line, this is your institute, if you see there will be multiple layers of the data. So, it is number of dimensions are there. and may associated with non-spatial information. Non-spatial means if I say this road is there, I can see, but there is a name in the road, right, type of road like a national highway, state highway, street, etc. So, this is non-spatial information. Like whatever the data set, those who have worked on databases, etc., you have dealt with mostly what we say non-spatial or attribute like banking data or say your student data, right. So, there are different records in the data, right. So, and this spatial data has some other property like they call topological property, like whatever you do with the map maybe. So, if Karnataka and say Maharashtra is sharing border, unless you tear it off, that relationship holds, right. What we say that if I say that state 1 touches state 2, it will be always there unless there is a huge catastrophe and earthquake, etc., everything breaks. So, right. So, there are other relationships which are not in the there. There is no thing called my bank record touching another bank record, right. Right. It may be something like if you have a joint account, you can say something is there, but or overlapping some of the things, right. We will see some of the applications. So, what we do, what we are trying to look at, if you look at the different type of application, one of the applications for the police department is finding the crime spot and type of things, being extensively used in several metros, like which are the crime spot, when it is happening, what is the periodicity of happening this, because the number of police or number of security person is much less than the number of population, right. So, if we want to make every person secure, then half of the population should be on the police, right. For everybody one should be there. So, it is not feasible. So, you need to find out that what is the occurrence of the things, etc. How do you see? Need to be a spatial map type of things, right. So, there is extensive analysis on being used for drought or flood type of things, like how things are there. There are things that finding optimal path that we are using with going from one place to another, and one of the thing is that prediction, what will happen when, right, whether we are expecting a what sort of crop, if this crop is there, how much yield will be there, or whether I am expecting what sort of a climatic change, etc. So, whether it is a micro level or macro level, there is a lot of prediction. If you look at little bit back with our CS, IT type of background, or we see that it requires a huge churning of the whole data set, right. So, there comes into the play that how this data set can act on, right. So, when we talk about data analysis, so what we are saying that we want to identify where it is there, right. So, I want to make a new department or a department building in SIET. First of all, you have to find out what are the potential locations, how it will be connected to the road, right, of the within the SIET. So, that requires a spatial context. It is not only textual context, right. So, we need to identify that which is my region of interest, right, whether it can be a small or a large area and type of things. I need to analyze that if based on the things that what I am looking for, what is my goal, what will be the thing, and then inference, like I want to find out that what is the inference of the whole thing, right. So, these are some of the things we try to look at when do a spatial data analysis, right. I will give you an example, like we are doing a project funded by Department of Science and Technology. They want to see that post COVID, especially so called economically underdeveloped regions, how they are performing, their livelihood, their migration, reverse migration, how they are performing, right. And see, that requires that where are the regions, which is meant by economically backward things, and then we need to find out that what is the meaning of livelihood, which is the economic factor, socio-economic factor, right. So, merging all different sort of data sets become a interesting problem. So, you might have heard hearing about or working on studying data science. So, if we put the spatial context in it, so we see that it has a different aspects altogether. So, whatever is there in data science we do have, along with that we have a coordinate or the spatial context inside the thing, right. So, it is a science of declaring spatial knowledge and explaining spatial laws about universe based on the spatial data, right. So, what we see, this sort of activity encompasses lot of interdisciplinary thing. One is definitely computing, data mining, machine learning, back to back the cloud computing aspect. So, it will see this. Along with that, we require a domain knowledge. Suppose I am trying to do a smart city, I need to know that what is smartness in the city is there. If I want to do some smart agriculture, then I need to have a domain knowledge of the agriculture. So, what we try to see that particular that somewhere that domain ontology has to be clubbed into the whole stuff, right. So, that in other sense, I am doing something without having a knowledge on the thing will not serve the purpose. Like suppose you are doing a library information system, you need to know how the library works, right. Otherwise, you need to have some person who can work on this library system, right. So, here so what we see, it is a multidisciplinary, huge big data, right. We need to be done, doing anything on the real time requires a different type of intervention. So, there is a concept which came up across the world, in our country also, called spatial data infrastructure, right. See, last few decades we have transformed from a data driven architecture to a service driven architecture, right. Everywhere, whether you are shopping through say Flipkart or Amazon, what you are buying? You are buying product using services, right. Amazon knowing mobile phone to shoes to furniture, it is not possible, right. So, that is a smart broker, right, something what yesterday lecture also is smart broker. So, you are doing that in turn connecting to different providers. So, we have a thing called consumer and provider relationship, right. Consumer can be provider also, provider can be consumer. So, this is we are now in a service oriented architecture, where the basic paradigm or basic backbone of the cloud philosophy is that service oriented architecture. So, we have a consumer, we have a provider who provides, and now as a consumer where I will find the services. So, there is a thing called registry or catalog. So, I look at the catalog or the registry, like you search in while booking a ticket in IRCTC or Make My Trip. You search that which are the train flights possible, and then you hook into that service and to buy other things, that acts as a thing, right. So, here also if I want to find out like if I want to make this say Tumkur to Bangalore highway from say 6 lane to 8 lane. So, there are a lot of things will come into play. What is the cut and fill of the things, right? How much road cut and fill will be there, which is a public holding or a private holding, then there are issues. Whether it is whether you will bring down a building or not, right, a school, etc. Whether it need to cross a water body, that is a different costing, right. So, if you see, in order to do that, you need to get the informations which are from a variety of sources. Road data is with the road transport department, all these land related data, there is a called land use board with them. If you look at the school, etc., with the educational department. So, there is a variety of who have the data, but integrating them seamlessly is a very costly affair, right. Either you have to download all the data, it is something very difficult. So, what we require an interface. If I give a query, it will search these databases and put in things. Once you want to do, the major problem with anything doing with this, whether you are doing cloud, IoT, etc., is the data interoperability, right. The way you store the data, way I store the data, they do not talk to each other. When the query comes, it thinks that it is a seamless data, right. So, those problems are addressed by the spatial data infrastructure, right. So, it is being extensively used for several purposes, especially for socio-economic planning in countries like US, Europe, they are having in place. In our country also, there is a concept called National Spatial Data Infrastructure under the Ministry of Science and Technology, right, though everybody collaborates. So, what it tries to do, it has different type of data set and it gives an interface by which different party can act things, from general user, means general citizen at large, to the industry, right. So, now in order to achieve this, there are, anyway, just we are discussing. So, there are almost in every field of our life, we have somewhere or another spatial context, right. There is a saying that 95% of the data bases across the world have some coordinate into it, right. Whether you look at your, if you say that I am in this department, it pins you to a department. I stay somewhere, it pins you to a location, right. So, somewhere it is you are coordinated or being attached to the things, right. So, if you see a number of or everything where require some sort of a special and in our country ISRO, there are Department of Science and Technology, Survey of India, NATMO, GSI, all are having custodian of the data. Not only that, there are different private players who keeps this special data into the things, right. And one of the major player in US, or they have all the data, like if you search for today's satellite image of SIET, so you can go to USGS and it is freely available for the thing. So, what we see this type of challenge? So, one is better. So, now we are trying to look at the point of view of computing and IoT and communication, that the focus of the things, right. So, one is first of all we need to have a better query system, right. Like a interface as good as like Amazon or Make My Trip, right. So, you give a query, it give you relevant result, then you choose from the things, right. Here also if you want to do provide somewhat real time resources, IT resources to enable real time applications. If especially it is required from disasters, like which road is blocked, how many things are there, like you might have seen in the TV recently in Uttarakhand near that Badrinath temple. So, there is a huge landfall, right. So, and thousands of things are trapped, not under the thing, but on the road. Now, they are trying to immediately estimate that where the things are there, how many vehicles are there, where should be if there is a need to be airlift, where possible a temporary helipad will be there, and they are trying to flown drone and putting on a map that what are the possible regions, right. So, in order to have that, this is real time, right. I cannot wait for 1 month, by that time, and some are non real time. I want to estimate that what will be the something production of coconut in and around Tumkur or in the Tumkur district. So, I can, it is not that I do it in a 1 hour time. So, there are variety from which are real time, which are more I have a lead time of the things. So, anyway, so deal with access spikes, right. So, in some time there will be a huge access spikes, right. So, like if you see in other contexts, whenever some central examination results is there, you immediately have a access spike means lot of people are accessing, otherwise it is stable. So, there is spikes in accesses for different type of data, true for this also. Provide more reliable and scalable service, right. So, I need a more reliable. So, if the service is not reliable, then there will be question that I may not be reluctant to use this, and it will be scalable. If I require more resources, it should I am ready to pay for that, it should plow more resources, right. So, cloud computing can be thought of a good platform for that, right. So, model for enabling ubiquitous, convenient, on-demand network accesses, already you heard about it, or you have already learned about it or read about it. So, this is one of the things what is that. So, so we try to see that how the spatial data can be enabled as a service using this cloud related things. So, maybe few slides little we keep the spatial thing into pause and see some of the things on the cloud which you might have. So, when we look at the cloud, so it is something a computing as a service, like electricity as a service. One big example is the telecom as a service, right. So, while using electricity, you never thought that which production or which generator has generated that, right. Neither when you are calling a long distance call, your service provider you will be knowing, like whether it is Jio or BSNL, etc., but you do not know that who is carrying and where other end what is the service provider, we are not bothered. Or even if you see when you are booking a train ticket, hardly any, I do not know, anybody have thought that who is the driver of the train, right, or how many bogies are there. You are more bothered about whether you got a window seat or something lower seat, upper seat, etc., etc. That means we are not buying data, we are buying services, right. So, they are also, so cloud is such a thing where the computing as a service, right. Rather somebody predicted somewhere mid 60s that one day they will come that computing will the service will as it will be a solution, right. But now with the more easy availability of hardware, good amount of good bandwidth at a lower cost, then it became feasible to have this sort of a service as a computing. And what it says already you may be knowing, one is that on demand self service, If I require, suppose I am working on something say basic thing like 2 GB system, for my computing I want to escalate to 4 GB or 8 GB or 16 GB for couple of hours, I should be able to pull it, right. When I do not require, I release it. Same thing in your mobile. Suppose you want to do a online course etc. class for 1 hour, you may be putting 10 GB of data on your thing, maybe paying some 20 rupees or 30 rupees or 40 rupees, but you do not require for the rest of the time. Whenever I require, I put it. So, that what we say, this is a on demand and should be self service, like while putting your say paying 20 rupees, your 20 GB or 10 GB gets credited to your account, you do not have to call that service provider, right. So, it is a on demand and self service, where the computing can be done on that, right. I require more data, I put that, right. Like some of the services already this computing services are used to it, right. Like those are using Dropbox, last day Professor Raj was mentioning, or Google Drive. So, what is there, that is your, we may be paying, suppose you require a 100 GB Google Drive space instead of your standard 15 GB, then you need to pay something 1300 rupees per year or something some per month basis, right. So, you pay, you do not have to call Google that you now increase the thing, you pay immediately instantiated, that is called self service, right. It is a resource pooling which is linked to that, I can pool resource and release. So, that means scale up and scale down. Broad network access, I require a broad network access, the connectivity should be there, right. Unless the network access is there, we cannot do. Rapid elasticity, which is again interlinked. So, I can go up and down, and measured service. So, it is a pay as you go model. So, once I use it, I pay for it. It is metered service, we are used to the electricity. You use more electricity, you pour more bill. You use more your, unless you have a what we say free call and etc. You more your mobile, you pay more for the things, right. So, it is a measured service. Those are the things is a computing. So, we are predominantly 3 infrastructure as a service, which give me a basic infrastructure like computing thing, or other end is the software as a service. We are using say Google Doc or different type of software services, which is a software as a service. You really do not know, right, when you are using Google spreadsheet etc., where the data is there, who is storing that, how it is there, you are not bothered. What you are telling, you are buying the service as a software, or intermediate I can have a platform, right. I have a platform to develop something, right. So, it may be a something say typically a Java development platform, right, or sandboxing for testing some of the things. So, there are different, there are several other services. I can say data as a service, right, like hey, hello, please do not talk. If you do not like, you can leave, but here do not talk. So, that is a what we say data as a service. So, that means say Google Drive. So, it is a data as a service, Dropbox, data as a service, right. So, data is somewhere, but you do not know, I have a Google say Dropbox, I just initiated from the Dropbox. So, it is somewhere in the things, right. So, there are things called, I can have different security as a service, right, or what we say typically anything as a service. Rather, I do not know, still the program is there. NASA started a program called science as a service. So, they will say the all data will do, you do science scientifically, specifically for academic world. Like USGS site we are telling, they are giving as a satellite data as a service, right. So, now what we have come to, like yesterday Raj explained nicely, we have a thing called what we say IoT to cloud continuum. Now, what is happening last 1 decade specifically, we are now very much rich on the resource. Like this mobile, though it is a bit old, it has a 6 GB RAM. My laptop has a 4 GB RAM, right. So, at least RAM wise it is more powerful. So, why not to put this compute bring to the edge? There are a lot of advantages. First of all, that data traffic will be less, right. It can, if I sense and do some of the things, say for example, I want to, for your lab in SIET, different labs are there or different departments, I want to have a temperature control. Everywhere I need to maintain, say we need to maintain between 20 to 25 degree centigrade, right. Now, one way is that you take the temperature, there are 10 sensors in every lab, it sends to a SIET cloud, so called, which is hosted in Amazon. That fellow take a call, that program, then they say that okay, this temperature is low, switch on the heater, that temperature is a high, switch on the cooler and type of things. You may say that we may can say that why to send, if there are 10 sensors, if one of the sensors is little resource rich, I can compute this 10, make a average. If it is not fluctuating within the 10 and 25, I do not send anything. So, what I do, I reduce this 10 center data. So, if it is done across the thing, so what I am doing, the computing is brought to this edge level, right. So, as our different devices, not only mobile, several devices are becoming more, so why not to bring it. So, so cloud at the top, intermediate is what we say fog, there is a thing called mist, dew and type of things, we are not going to that, then push it to the edge. And it's now it's a era of IoT, everywhere you see sensors, right. Anywhere, everywhere, whether this is a camera or temperature sensor or a drone or everywhere you are being mapped, right. So, what we see that bringing this to the down to the sensors level maybe makes sense that things. There is a one advantage, I do not send the raw data, especially the data suppose it is a healthcare data, right. So, I may not want to expose. In our country so much stringent things are not there, but if you look at Australia or US etc., they are very fussy, truly fussy, because your personal data is for your personal purpose. Nowhere it should be disclosed about your medical information unless the authority has the you and the authority has the way to do that. So, if I do a processing, that the upper layer that is getting a processed data, not a raw data. So, that means I can have not only what we say save on the bandwidth, I can have something on anonymity also, right. I can make it anonymous and I do not expose it. So, this multi-layer thing is becoming here. Along with that, we can build different type of intelligence at different level, right. So, they are resourceful, like if these are edges, so they can do some applications, I can give different intelligence, like suppose I have a health band, like yesterday Raj was telling, if some parameters is there, it will not do the medical diagnosis, but it say, no, you need to visit a doctor. Or you need to take a rest, you need to take, if it is something come to flash it, right. So, some sort of intelligence at level, if I see lot of people are having the same thing, then that should have flag, right. Like if you might have seen that there was some gas leak, I think somewhere in northwest of India, I forgot the region, maybe Chandigarh area or so. So, there was a gas leak. So, same type of symptom, if more people are showing, it is not a single person problem, right. So, could have been tracked that this need immediate intervention. So, there can be lot of applications for that. You can have things like flooding, things like other disaster etc. So, which can be done as a much regional level, like which has the different fog nodes, right. And these days you might have seen that yesterday also we, in case of things like smart car, driverless car, even if you do not go to the driverless, this we have concept of V2V, V2I, like VANET, Vehicular Ad Hoc Network, which can communicate between vehicle to vehicle, vehicle to infrastructure, infrastructure to infrastructure. Those there is a setup which is there, and there is a standard for doing those things, right. So, now if I see something road jam due to maybe collision, due to maybe some other reason, then I can basically send this type of information which is local, like a road jam in Tumkur is nothing to do with something at IIT Kharagpur. If I send that information to IIT Kharagpur that there is something road jam near SIET in Tumkur, it is a burden for me, right. So, I can do a geo fence, right, fencing on a geographical thing, and maybe the fog node or type of things can take a call on the things, right. And the cloud is more of a large analytics engine, right, which can do different predictive model. If we see that every day this region of Tumkur is getting jammed, they need to be looked into, whether the more roads are required or more traffic lights are required and etc., right. So, it has a spatio-temporal analysis, right, over a big span of time, right. So, what we see that it is something which is come from the edge, same picture little bit. So, bringing intelligence down from the cloud close to the edge, right. So, cellular base stations, network routers, Wi-Fi gateways, this can act now as a thing. Like if we there was a study like what they say that this like that Cisco is one of the predominant player in the networking, you all knowing, right. What has been seen across the world, Cisco devices not even 50% loaded, right. Not during the spike, but most of the cases they are 50% resources are free. So, it can basically the fog was coined by Cisco so that they give that this particular switch can do other operations also, right. So, processing close to the device lowers the response time, enable real time application and type of things, right. So, if we bring down the processing lower to the ground, lower to the n mile or low things, that may be that will be a feasible solution. So, another thing came up, again it is not possible to go. There is now what we say that so what we are doing basically virtualizing things, right. So, I am not having a machine, I am a virtual machine from Amazon, still I do whatever work I am doing, right. I want a interface and do something, right. You do not have MS Word or MS Office, still you can use say Google Doc or Google spreadsheet. What you are doing? You are having a virtual software, right. So, the core of the thing is the virtualization, right. Now, people are going little more than that, like yesterday also discussed that why not to enable at the function level. I may not require machine itself, I require some functions to be executed, right. So, or there is a concept called container or containerization or containerized based services. So, what is a container? What we mean by container? The first picture come especially in national highway, big trailer taking that containers, right. So, why that shape? Actually that shape is a very standard shape, it fits into the ships, started with that. So, you see that large trailer carrying containers, so they fits into the thing. Now, it is being carried to the other end. See what they look at? They basically look at the size which is fixed maybe and the weight of the things, right. They are not bothered what is the, not bothered means customs may be bothered, but as such they are not supposed to be bothered what is inside there, whether you are sending food grains or say books or iron rods, it is inside the things. So, it is being containerized. So, the end party knows what to be opened up, right, like something which is a standard package of Amazon coming to your hostel or home, right. So, that who is carrying that fellow is not supposed to know. Previously they are giving the items, now they have abolished that items also. So, he only knows the source and destination, you open up the things. So, you know that what is the use and the source from it generated, it knows the things. So, so now it becomes a thing. Now, I require a software which needs on my mobile or this particular device to check the temperature during something, right. So, I pump a containerized service which is explode in this thing only, right. So, I do not require much, again I am more granularity in the services, right. So, containerization microservices is playing a major role, where there are different services, one this container with type of thing. So, initially this is the monolithic traditional, like you have a hardware like my laptop is operating system like Windows, and we have different application now PowerPoint, right, or different type of applications. Then we graduated that hardware and then operating system, then is a hypervisor which creates different chunks of machine. Like I have a hardware of 64 GB and I want to make a say 4 GB 16 machine out of it, right, and one Windows, one Linux, one Mac, etc., different variant of Linux. I give it the 16% of 4 GB systems. You connect over the internet, work on it. So, that is a what we say different virtual machines, right, what Amazon is doing and type of things, or different services. You can have your own thing called OpenStack or Eucalyptus, those are the open source cloud you can install, even in PC you can have different virtual machines, right. So, in the container what they say that you have a runtime container of the things. The beauty is that the demo is that running demo is not there, I could have shown you, like we have a thing like a web server or working with a database can be containerized with all dependency, can be put to another machine, it will explode that and start working. I do not care what the machine was, what are the configuration of the machine, so long this container runtime is there, I can basically run that thing, right. So, what we are trying to do, it is now your services are interoperable and hopping around the things, right. So, you become more flexible, dependency becomes less. So, you carry the dependency. So, containerized means like all my thing and dependencies are containerized into the thing, and I send it to some other systems and it explode and run. So, this is also becoming or rather nowadays what we look at containerized microservices and all those things. And this is some other way of looking at it. So, with container services, this picture is not very clear, that I can enable microservices and things like that, and it can be work into different underlying network. Now, coming back to our the thing what we studied. Now, the spatial analytics as it is a hugely compute intensive, data intensive, and whatever network intensive, whatever intensive you can think about, a truly a big data type of scenario. So, it can be a good candidate for making this type of cloud computing, right. So, search, access, utilize geospatial data, configure computing infrastructure, adopt spatio-temporal principles, right. Space time, how things are changing over time and things, which are one of the need of the day, right. So, whether you talk about climate change, whether you try to predict what will be the rainfall, what will be the crop prediction, what should be the event in big cities, what should be the traffic prediction there, if there are intervention like yesterday Honorable Prime Minister came here, there will be some blockage on the road, right, how the detour should be planned, that all those things you require some space time context, right. So, it plays an important role. So, spatial cloud have all the cloud properties that is driven by the geospatial science, optimized by spatio-temporal principle for enabling geospatial science discovery and cloud computing within distributed environment, right. So, try to show it as a example scenario where you want to use a huge big data type of application on this type of scenario, right. So, there are I am not going details into the things, so there are things like network, servers, apps, services, storage, containers, microservices, all are need to be enabled. So, managed service prevent data loss from frequent outage and type of things, right. So, as you know that in cloud data storage has a principle of three-way replication, right, means any data say stored in say for example Google Drive or your Dropbox, it is a three-way replication. That means one of the things will be there. Three-way replication, one way good, that one can serve. The problem is when you have an update or write, right. So, in the three writes should be successful, at least three-way replication should be there. That is the basic principle which came up on the Hadoop and type of things, right. So, here also, so if this is a big data, huge data, then anything replicating has a huge load, right. So, how need to be managed, those things has been thing. Like one is the theoretical way of looking at it, one is the practical way of implementing it. So, there are easy to use, which is same as the cloud. Scalability, I have more resource things. Cost, optimize at the resource use base. There will be reliability. So, I can have now I can host of enterprise grade things. Like if you see that your hard disk may fail, how many times Google Dropbox has failed? I am not never seen from the inception, right. There may be service down, but data is never lost, right. So, it is a huge amount of reliability, right. So, if you pay, you are there, the services are there. So, a typical structure here, the context is in type of spatial context. So, we have all the properties like infrastructure, platform as a service, software as a service, storage as a service, those things. And when we talk about spatial data, so first thing what will come to our mind, to view the data. Any map I need to view, right, whether it is a Google map, Bing map, etc. So, that means what we say web map services. Secondly, you may say that I do not want to view the data, I want to extract the data from the things, like how many say food outlets or particular things are there in Tumkut thing and where are the locations. So, I want that information out of the things, right. So, it may be that what is the traffic congestion level at 10 am on Mondays or on Tuesdays or every Mondays, like this I want to make a plot that how it varies over the things, right, in a particular crossing like Sri Hanumanji crossing, I do not know what is the name of the crossing. So, they are there. So, we can have those type of things, like it is a space time things, right? I can the district authority or the city authority want to plan that how things will be there. So, there are different type of services, again we are not going into the details of the services, and we can have different implementation of the things which is same as cloud type of implementation other, but here in the spatial context, right. So, we have a spatial registry. Registry is a typical thing, right. So, I do not know any of you are using thing called Truecaller, anyone? Yeah, great. So, what is the Truecaller? It is a registry, right. So, it shares data like I become a member, you become a member, he become a member. So, what will happen? So, they are using the contacts, creating a registry that given a contact other details like first of all contact to name and maybe other details like where, which area, etc., etc. Now, when you get a call, so the Truecaller pop from the registry. So, it is a registry service. So, registry is a thing which says that where to go and etc., right. Maybe a small way registry is your at the down at the next of the this side of the lift there is a I3 cube one printout is there, na? This floor 1 this hall this session, floor 2 this hall this session, that is a registry. Otherwise, you have to this 4th floor you have to go around, where is this stock, there is stock, right. So, registry gives a metadata information. The information that detailed information is inside the thing, right. Your book content is a registry, a reverse registry is the index, right. So, there are all for we call it registry, there are some other things which we call as a catalog. So, any information system, right, specifically when it is a very large requires a catalog system, rather they say this registry service is the key of the whole thing, right. You take out the registry from the things, it will be a mammoth task to basically search services, right. So, this is the way how we do. I am not going again to the details. So, what we will do before conclusion one or two, I think I have another 10 minutes or so, right. So, some use case of one of my scholar that I will just wait, what happened? I made some mistake, 1 minute. It will come up. No, actually by mistake I pressed a different key. 1 minute. I should press escape. Whatever. Why it is not popping up? I want to open this PPT. Maybe taking little time. Huh? This one.
Yes, sir.
It should come actually F4 or something will be there. No?
Yes, sir. This is a MacBook now.
Huh? No, this is not MacBook. This is simple Windows. That next one.
This one?
Right. This one. Right. It is coming here. It is not going there actually.
And another key.
1 minute. Something happened, right? Here somewhere.
Just give it.
Right. How to expand it? Wow, great. Yeah, right. This is the thing. Thank you, Professor Satish. So this is some of the use cases will show. This is work done by one of my scholar who is in now in Penn State. We also closely worked with Professor Raj, and rather I to thank Professor Raj for giving lot of university related student data. Anyway, I may request sometime to Dr. Dinesh we have some of the data here. So, some of the applications that how the spatial IoT cloud actually works, right. I am not going detail, but maybe something there, right, we will go. So, we did, so there are several applications like transport, telecom, profile based marketing, right. I want to look at the profile of the things who is, there is lot of things are there with especially malls etc. coming up, how much you are visiting or window shopping actually buying, which profile are buying more to give more incentive to the things, right. So, rather there are application of taxi, GPS, daily route of buses. One work we are doing with Calcutta Transport, like with their now buses are all fitted with a GPS, what should be, whether there is an anomaly in their travel time, right, what is the cause of the things, whether the anomaly is repeated on some occasions like every day, every time, every weekend type of things, whether there is an intervention type of things, like. So, daily GPS footprint, travel logs, check-ins, mobile phones etc. So, there is a huge number of applications how things are going, whether it is a local transport, airport and etc., right. And especially what we see typical situation like hurricane, tornado, even migrating birds, migrating animals and type of things, right. So, so what we see that is IoT these days is everywhere. Your mobile device is capturing lot of things that they say that around standard mobile things now we are having somewhere around 64 sensors which we may not be using, but somebody can be exploited. So, one work we did that for trajectory information of this is called that with the help of students and also staffs and faculty members, like if we share the trajectory information, there is a in Google there is a trajectory line that is timeline you can share, we can basically avoid the your personalized information. I don't want to identify the things, like if you are supposed to come to the class and you may be gone to a food outlet, that we do not want to exploit, but we want to see that how this over the road network, what is the way people are moving, right. A typical study we did, we thanks to Professor Raj for a help that from the University of Melbourne also we got some information. So, typically structures are somewhat same, right, like that, like if you see the IIT Kharagpur structure, like there are hostels, those are residential, there are academic units. If you look at any NITs, same philosophy, there are hostels, there are halls of residence, academic units, classes are more or less in the same structure, that is everywhere in any institute in India. So, there is something which is predictable, like morning there is a lot of traffic from the hall to the lecture halls. Evenings are again traffic, but that is scattered, right. So, not that everybody is in a relaxed mood and type of things. So, whether we want to try to see whether we can predict that what sort of congestions or what sort of traffic movement will be there. Not only that, we try to predict whether this is a student or a faculty or a staff or a outsider by the movement patterns, right. So, whether it is possible. There is another interesting thing what we tried here, like whether we can predict the infrastructure. Like if I know the structure of IIT Kharagpur, like this is hall of residence, that is physical or the spatial entities and the movement patterns, and I know that some other say IIT Bombay, they also have this type of philosophy, but I do not have the spatial objects. Looking at the movement pattern, whether we can predict this is possible lecture hall, this is a portable food court, this is a possible ATM, this is a possible hall of residence. In other sense, looking at the footprints, I want to make a physical map of the region, right. This may be useful for different purpose, maybe for military and other defense purpose, and as these footprints are captured by your service provider, like different telecom service provider, that may be much easier to get and make a prediction out of it, right. And there can be lot of things, like we never thought, but this your city planning authority of Kolkata, they told, there can be a study that because there in Kolkata there is a very congested, right. So, number of say percentage of road is much less than the expected and things, and now there is a extension in the new town area we told. So, they are telling that what will happen in new town say 20 years down the line. So, what should be the planning now, right. So, they are having their own way of looking at it, whether in the spatial context this. You can learn from what happened to New Bombay and type of things, and then say that what is going to be there, or other major cities, India, across the things, right. So, you see the application is a different scale altogether, right. You want to have some predicted model with spatio-temporal prediction into the thing, right. So, for that we have used some of the cases cloud enabled spatial data infrastructure, right, where framework to analyze behavioral pattern of moving agents in a timely manner. Moving agent may be human being, moving agent may be cars, buses, etc. So, this we try to use that GCP, Google Cloud Platform, for this purpose, and try to predict that use the spatio-temporal prediction to find out that what is the whether there is a prevalent prediction pattern into the things, right. Like what is expected to be the congested things. These are very, though sitting at Tumkur you may not feel, sitting at IIT Kharagpur also we do not feel that what is the thing, but if you are in the Bangalore, any type of disturbance into the network, or means transport network, it creates a ripple across the city, right, and some are immediate, some are maybe 1 hour down the line the ripple will propagate. It is like that, if there is a flooding somewhere, so immediate something is flooded, some things are get based on the elevation, etc., right. So, how to predict those things? So, we use that cloud related things, and Shreya developed a full fledged infrastructure which works, and we tried with different data sets. So, what we termed as a MOBI IOST, mobility driven internet of spatial things, right. So, and shown that there is a using this sort of structure we can have a good amount of reliable prediction of the traffic, taking previous year data and type of things. So, so there are several location driven services. One such we use for navigation purpose, or finding nearest something like nearest shoe shop, nearest food court, nearest car washing, nearest McDonald or nearest KFC. Those are location driven services, right. The services are location driven, right. So, these location based services commonly known as LBSs, right, LBS. So, these are becoming, not becoming, it is extremely popular and gives a lot of revenue to different things like Google, though they are free, but they are having lot of revenue out of it. So, this is one work. So, what we did with the mobility and health analytics, like we used a locator and type of things, rather due to and also use this fog, edge, for cloud type of infrastructure, try to see that whether it fits, how it fits well in for this type of context, rather due to for the so this is one such application. I will show you some application, those who are interested we can, and you might have heard about map reduce type of services, right. So, we use map and reducer phases to optimize the services, and there are several other applications like extracting correlation between mobility behavior and other contexts, like there is a mobility and other contexts, right. Like if you see your day to day routine, like you morning wake up and brush your teeth, hope all of you brush your teeth after getting up, right. So then you have a thing of tea, taking tea or coffee or milk, etc. Then breakfast, coming to college, weekdays behavior, weekend behavior. So, there is a context of the things. It is extremely useful when we are trying to address this old age type of things, right. Now, with our sort of a so called quote unquote nuclear society, most of the cases in case and with the life expenses increasing, you will see that lot of at old age many people either means in pair or single staying alone. There are activities like when to take medicine, etc., or that movement maybe within the house area maybe need to be tracked. We have lot of devices things. Anyway, so this is mobility behavior, and with other context what we did, and trying to see that how different mobilities are there, who do what activity can follow, if there is activity skipped or something that may generate a alert and type of things, right. Here like science lab, classroom, and try to map our activities into the things, right, and try to have a mapping, a heat map of the things that where how people are present, right. So, there is another application of internet of health things, use some devices to capture something, some thing what Dr. Raj was Professor Raj was mentioning, and it was put on the services, either your health, and we made a customized device which captures different type of information, not a very big deal these days. You can have all these devices available, you can make a things with your 3D printer, etc. You can have a not so slick handband, but you can have a good looking handband at least. So, we also did some of the things and try to find out different contexts, and again as a service how that registry and catalog and location based things, try to put the data along with the location and time, right. So, and also tried during this, everybody tried this something on the COVID. So, once Raj was mentioning how many 5 lakhs papers, right, generated, 500,000 research article generated. So, we tried to contribute 1 or 2 out of it. So, these are some of the things. So, pandemic knowledge graph, and that is so creating a knowledge graph. So, and there are other thing called femtocell, using this, bringing this communication to the thing, right, and especially this is some of the things useful in high rise buildings. If there is some exigency, what should be the moving pattern. Not only that, even movement of the file in a particular government office, that is also big challenge, right. So, there are some of the things which we tried. So, maybe let me conclude now, because I think done more than 1 hour. So, what we see that this spatial data science, which encompasses other than the spatial information, this cloud, fog, edge, microservices and containerized based services, is a pretty I should not say emerging, already somewhat emerged field, and has a huge application, not only potential for the research, also from the revenue point of view, right. People are making, or large companies are making lot of money out of it. So, it may be interesting, and that does not require a lot of investment, right. It requires more of a collaboration and getting data, etc. So, it will be nice, you can try it out, you can have your own cloud infrastructure like open source, like OpenStack, and even you can download Aneka excellence tool for managing all those services and have some context into the things. Okay, so with this, let me conclude my talk. I should what happened? So, let me formally thank you for your time, patience, and so any query if you are having, I will be happy to respond now or later on, whatever you feel like. Right. I especially want to acknowledge all my students who are the prime mover, collaborators, and we are, myself and Raj is having a Spark project. Thank you all. Yeah. Yeah. Yeah.
In cloud computing, if we don't have large amount of data, so then it is mandatory to use hypervisor.
Yeah. So, if I reframe the question, if you do not have huge data load, right, and if you do not have say huge application either, then whether it is mandatory to go for first of all cloud computing at all or not, right, and then going for hypervisor. Hypervisor is a way to realize virtual machine. Truly speaking, may not always, right. So, there are two things. One is that you have a huge amount of data and applications which may need something resources which is not you are having at your hand, like maybe laptop, desktop. Another is that some of the tools you may not have it, right. Suppose you want to do something with the MATLAB, even the data load is less, but you do not have MATLAB license, but whereas you can use the cloud MATLAB like this, right. So, if it is truly speaking, if it is manageable with your systems and the data load is not high, that cloud may not be required. But if you require some of the services which are being rendered, then you may require this type of services. So, at what level you services you buy is important. Yeah. Good morning. We are doing that exactly, trying to show that how data science or special data science can exploit a cloud computing, right. So cloud computing is a giving you a computing as a service. Now, whether you want to use for the data science purpose, whether you want to use your traditional something, say banking purpose, so that's up to you. So, it's more of a computing framework, right. Definitely you can use. Rather, as data science has a huge volume of data, to make really sense, you need to have large volume of data and applications. So, that may be a good platform which you can piggyback on. So, that is the basic framework, definitely. So, yes, your one is there, yes, it can be used. Thank you. Yeah, please. Yeah, good morning. You can come here and ask. I will repeat your question in the mic.
Hello? Hello?
Yeah. Private cloud. Yeah. So, I have not mentioned, but yesterday it was mentioned about, Raj mentioned about the private and public cloud. So, the philosophy is same, private is within your boundary, right. So, some of the things you may not go, you may manage, right. Suppose your examination system, you want to have a private cloud, but you may, some of the things you may have a public cloud also, or you may have a hybrid cloud also, public, private, intervention. So, if the organization feels that within the private cloud it is fine, in IIT Kharagpur we are having a private cloud called Meghomala, which is not accessible outside the IIT Kharagpur network. It works, it's fine, but some of the things we are subscribing from Amazon or Microsoft Azure. So, if your organization thinks that with the private cloud things are there, it's fine. So, both philosophy is same, right? Okay. And there is another, what we say, community cloud, in the sense that, like say banking sector can have a cloud, or academic network can have a cloud. So, that is some sort of a hybrid or in between which has a thing. So, as to answer to a thing, if the organization is good, is fine with the private cloud, absolutely fine, no issue on it. Thank you. Okay, thank you. Thank you. Mic and this, somebody has given me this one.
Thank you. I will do it. Thank you, sir.
Thank you.
Okay, sir. Welcome. ಸ್ವಲ್ಪ ಹಿಂದಿಗೆ ತಗೊಳ್ಳಿ ಸಿಸ್ಟಮ್. Okay, sir. Just give me the remote access.
Yeah, okay. No, I will put mine. Okay.
You are, sir. Thank you.
Because like then I am comfortable.
Suresh, sir. ಬರ್ತೀನಿ ಸರ್. ಪ್ಲೀಸ್ ಹ್ಯಾವ್
ಇದು ಬೈಕ್ ಇದೆಯಲ್ಲ ಅದೊಂದು ವಾಲ್ಯೂಮ್ ಸೆಟ್ ಮಾಡ್ಬಿಟ್ಟು ಅದನ್ನ ಕೊಡಿ ಹ್ಯಾಂಡ್
ಬರ್ತಾ
No, I will be here because like now you are blocking me.
ಥ್ಯಾಂಕ್ ಯು.
Because like you are blocking me. Okay. It is better that I walk that.
ಸರ್
ಸರ್
ಪ್ಲೀಸ್.
ಐ ಪ್ರೊಟೆಕ್ಟ್ ಸರ್.
Yeah,
Thank you,
please.
sir. Take it in, sir. I will put in your pocket, sir. That is a YouTube mic, sir.
YouTube mic. Okay.
ಸೆಟ್ಟಿಂಗ್ ಮಾಡಬೇಕು ಕ್ಯಾಮ್ರಾ ಹಾಕೊಂಡು
ಏನಾಯ್ತು?
ಎಲ್ಲ ಬರ್ತದೆ
ಬಿಡಿ ಇರಲಿ
ಓಡಾಡ್ತಿರೋ ಮಾತ್ರ ಎಲ್ಲ ಬರ್ತದೆ
ಸರ್, ಅದೇನೂ ಆಗಲ್ಲ ಇರಲಿ. ಸರಿ ಸರ್, ಟೀ ತಗೊಳ್ಳಿ.
ಪ್ಲೀಸ್ ಕಮ್ ಹ್ಯಾವ್ ಟೀ ಸರ್
No, I don't drink tea. It's okay. Thank you. Am I audible? No?
Sir, give one cordless mic as well.
Yeah, okay, okay.
Sir, you want to
Ah. Ah, okay. So what you
5
want?
to 10 minutes, sir, they will come back.
Yeah, okay, let them. Okay. Indian 5 to 10 minutes. Okay, right.
Okay, sir.
No, but this one. This is fine. This is fine. Yeah. Okay. It is like this.
It's audible.
Okay. Right. I'll do that.
I'll send them in, sir.
Okay, ma'am. You're comfortable now.
Yeah. 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 Yeah.
That is why I was searching you. The moment you went there,
No, I was in.
but as you go here,
No, but then like you cannot hold them for 2.5 hours, right?
no, the moment you journey to some other discussion, everybody will talk, others will think, oh, this is what,
Yeah,
this
that-
is story will go.
Yeah. No.
When the thing continue, they will continue, and this you can
No, but 2.5 hours like with this crowd, like you cannot.
explore, no, not too much of basic. So that way you focus more forward, you see new.
But I have to bring the crowd, isn't it? I have to see the crowd like with me first.
That is what I told them to get them. They say 5 minutes, 5 minutes.
Not getting them in, getting them here.
So what is 5 minutes in here?
Huh? Photo. Okay, right. There. For me. Okay, for.
Can I? Water, please.
I think if you open inside.
There is water. Nothing.
I'll arrange.
Okay. Right. Excellent. బాటిల్ అనుకోండి, వాటర్ బాటిల్ బ్యాగ్లో ప్లీజ్. థ్యాంక్ యూ. ఓకే ఓకే, యూ కెన్ బ్రింగ్ వన్. థ్యాంక్ యూ. Why?
So to change shell. So is it comfortable for you to see the screen from that side?
It's okay. It's okay for me. Hello. Hello. Hello.
You are comfortable with that?
Yeah. Okay.
What is the duration, sir, approximately?
Again 1 hour, but then like I may reduce. Okay. Okay.
Hey, it's nice.
Right. Good afternoon, guys.
Silence, please. Everyone take your seats.
Okay, right. So, good morning, guys. 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 Now everybody is with me? Still not? Okay, if everybody is focused here, then I will show you around the globe, okay? If not, you can be in your world. Right. Okay, right, let's start, okay? Good morning, guys. I am Satish Rama. I will be talking about cloud and fog edge computing based Internet of Things. By the way, how is it audible? Is it audible like this, or like this? The first one was best. Okay, right. So, I will try to see the session also a little bit interactive. It all depends on how much you basically focus. So, I am leading Cloud Computing and Smart Solutions Laboratory at University of Hyderabad, India. Earlier, I was leading Mobile and Cloud Computing Laboratory at the University of Tartu. Okay, I am the honorary head of there. Okay, I returned back to University of Hyderabad only in 2020. Okay, before that one, I was with University of Tartu. Whenever I show this one, people will ask me a question. Yesterday, somebody presented you in the workshop, online, demo. Who is he? It was Shivananda, isn't it? Shivananda presented, demonstrated Aneka Cloud from Estonia, isn't it? But how many of you know where is Estonia? How many of you know where is Estonia? How many of you don't know where is Estonia? So, the rest of you know Estonia, where it is? Okay. So, Estonia is a small country in European Union. It stays there next to Finland. Okay. And Tallinn is the capital of Estonia, and Tartu is the second largest city. With the whole of Estonia's population is just 1.3 million. Tartu's population is just 100,000. What's the population of Tumkuru? Approximately? 100,000? 50,000? Nobody knows? Nobody knows? It's not properly audible? It's not audible? It is not audible. I mean, like, my question is clear? This is, I think it is YouTube mic they are saying. Okay, then I will switch to the other one. Okay, we don't mind. Yeah. Now am I audible properly? This one? Okay. Now?
On the mic, sir.
Hello? Both are off? This one?
This one also, sir.
Yeah, this one? Hello?
Talk.
Am I properly audible now? Okay. So I thought like it will be more interactive, but now I should be okay, I should just stand here. It's very tough thing to basically tie me up at a place, but let's try how long it can tie me. So coming back to the same thing, Estonia. So I was asking like what is the population of Tumkuru? 27 lakhs. Okay. So Tartu is 1 lakh population there. So it's a small city. Okay. But the interesting thing is, it's very beautiful city, European, and then like it is well known for its flora and fauna. This is how the university center is. Okay. And this is how it is in Christmas. But the interesting thing is, since it is in the upper hemisphere, there is a lot of snow around. Okay? Isn't it beautiful? Okay? If it is not beautiful, I don't have anything more beautiful than in the rest of the slides. Okay? So, this is how it looked from my window some years ago. Okay? So, that's Estonia. Why I am showing you this is, you will know it from the rest of my presentation. The snow is the context. Snow is the context there for several of the IoT applications which I will be talking about. Even though like the population is really small, okay, it is only 100,000. University of Tartu is very well known for its academic recognition. The university is established in 1632, 400-year-old university. It's one of the top 250 in the world. Okay. So good. That's a little bit of background about me. So basically, today I am from University of Hyderabad, but still I am a honorary head at University of Tartu. Okay. So basically, whatever the case studies which I will be talking, some will be in Estonian context, some will be in Indian context. So that's why like I have given you that background information. Thanks to Professor Ghosh, he talked about some of the basics, introduction, everything he has given. So some of the things like I will rush through. Okay, not necessarily I will be going through all the things in detail. Okay, but we will try to see like what more. Okay, and what our lab is basically dealing with. So we will be looking at cloud centric IoT, fog computing and its research challenges, fog based IoT, and rest of the case studies. I don't have to talk about this one. So IoT, you all know about it. So many examples. Say for example, in the same room I can deploy different sensors which actually can measure the CO2 level in this room, humidity in this room, how many people are there in this room, how loud is this room. Based on that one, whether to open any door, whether to open any window, okay, and noticing like how many people are there who are talking, whom to basically send them out, okay. So we can think about lot of interesting scenarios, isn't it? So a lot of interesting IoT scenarios can be designed using these sort of things. Why it is so important? Because there are certain predictions like billions of devices will be connected by year 2025 itself, okay. So this, the number of people who connected to the internet, I mean like number of devices which are connected to the internet is more than number of people connected. So this happened way back in 2008 already. So this is not new completely. So lot of interesting IoT based applications are possible. So in the last presentations you have seen like in smart homes, smart cities, different domains, okay. I will be stressing only when it is required. Actually, now people are talking a lot about IoT. We have established this Internet of Things and Smart Solutions Laboratory at University of Tartu way back in 2016 with the funding from Telia. Telia is the biggest telecommunication provider in Baltic region, okay. With their support like we actually have established that one. What we were doing? We had test setups for smart homes and smart office scenarios. In Europe, we generally work with several European Commission projects. These things will be on the order of several millions of euros. Say for example, this project which I am showing you worth 4 million euros. So in Indian terms like it is 50 crores. So the research institutes are no less than any software industry in India, okay. So take those things. So these are all practical experiences. So the real things which are tried and demonstrated, okay, and then like deployed in the cities. So what it is actually shown there? I had shown you earlier about Tartu. The photo which you liked the most, what was it? With lot of ice skating and then like lot of snow around. But the catch of that one is, if you want to survive in such an environment, you need to heat your apartments, isn't it? So heating the apartments, how do you heat the apartments? Here we are not used, we are generally heated, okay. The sun itself will heat us basically. We will reach like 40 degrees centigrade, blah blah blah, okay. So for us it is not a problem. But the thing is like in Estonia, it is gas which is actually used to burn and heat the apartments. So that is the one of the biggest problem which European Union is today facing because of the Ukraine and Russian war, isn't it? You hear a lot about like European Union more or less needs like Russian gas to burn their homes, and that is what the plugging, okay. So more or less like choking point for EU. especially in terms of this war is concerned, Ukraine-EU war is concerned. But the point is, you have to burn the gas to heat your apartments. Now the point is, it is very expensive, burning the gas and then like heating the apartments. Even if you can save like 2 to 5% of energy or an year, it will be a huge saving for the whole country. So that is their challenge there, major challenge there in terms of looking at it. Now, of course, Estonia was erstwhile USSR country. So with that sort of setup, there is also a little bit of advantage. The building which you see there, it is actually a Khrushchev era building. Khrushchev era means, so from the erstwhile USSR, he was one of the erstwhile USSR president. The interesting thing is, the same type of buildings are everywhere in the city. So that means like if you can deploy a technological solution for one building, it can be deployed across all the buildings. So you can save a lot of energy. So basically in this project, we were actually studying different deployments. So we were trying to save the energy using, say for example, different temperature sensors, environmental sensors, etc. We were saving the amount of gas which is to be burned. Okay. And in addition to that one, we also have studied, I am talking about the things from 2016-17, isn't it? That's when like Internet of Things, not many people knew about it. So we deployed these solutions. We were also interested in like how people are interested in using these sort of technological solutions, or how to encourage people to basically use these technological solutions. We were trying these things. And business models, how basically companies which actually deploy these solutions, how they can actually make money out of it. Good. So that's about the IoT applications, case studies, what we were working in general. But then like if you really look in terms of these IoT things, IoT applications, you can actually design them in terms of different layers. At the lowest level is the sensing and smart devices layer, from which you collect all this sort of sensor information. You put it at the gateway layers, from there you push it to the cloud and process it there. So this architecture is actually called cloud-centric Internet of Things. If you look at each and every layer, the lowest layer is this sort of sensing and smart devices layer. This is where like all the sensors, different applications which I am talking, temperature, humidity sensor, etc., opening and closing the doors, actuators, which actually fit into that one. And this is the layer which also deals with this sort of communication protocols. Okay, so which actually using which like you can actually collect all the information. So something like Zigbee, Z-Wave for smart homes technologies, and of course over the long distance things like you can use LoRaWAN, etc. So to collect the information. Of course, microprocessors and controllers, something like Arduino, Raspberry Pi, also basically belong to this layer. Then the next higher layer is you have to collect that sensor information, you have to store it somewhere, then you have to push it to the cloud. That actually brings to the scope of gateway layers, which is in the middleware layer, where you are actually collecting the information. Okay? But the gateway layers actually makes one interesting thing possible. My mobile phone can also become a gateway. Why it is interesting? You know how many number of sensors are here? How many sensors are in my smartphone? Literally everyone owns a smartphone, isn't it? Anybody here not owning a smartphone? That's interesting to know. Huh? Everyone has. How many sensors are here? Several. What number? 500? More than 5? 5. Okay, so we have a huge scale, 500 to 5. Where? Huh? Around 70 sensors are here. 70. It's very interesting information. This mobile is a huge cheat for you. It has 70 sensors. It has, say for example, some of the standard sensors, something like accelerometer, gyroscope, using which I can tell whether you are sitting, whether you are walking, whether you are running, whether you are sleeping. Okay, of course, with additional sensors, I can tell about your heartbeat, etc. I need to connect with my Fitband. I have to connect to that one. Not just that one, it knows a lot of your personal information as well. Where you are located, okay, and when you are reading it, whether with what seriousness you are reading as well. Say for example, if I am reading something like this, I am doing it casually. If I am reading it like this, I am serious about it. So all this information can be extracted. Not just that one, it knows about my personal information, where I am, which websites I regularly use, which sites where I buy different things, during a particular day, like where I am generally going to, what is my general activity schedules, everything it knows. Can this information be used in different applications? Exactly. So that is the basically how like mobile is extensively being used in terms of different IoT based applications. Just now, like you also heard from Professor Ghosh about web services architecture. So you will have a consumer, you will have a provider, you will have a registry up, isn't it? If I have to inject a mobile into this architecture, what is the logical place? What is the logical place? I wanted it to be an interactive session, okay? So what is the logical place? Whether it would be a consumer or it would be a provider or a registry? Which one you think mobile? It's very easy for it to take the consumer's place, isn't it? But it is possible to take the provider space as well. Okay, you can think about your phone itself is a service provider. This is not a completely new concept. This was my master thesis in 2003 with Ericsson Research in Germany. Okay, so I did my master's and PhD from RWTH Aachen, Germany, and I was also intern at Ericsson Research in Aachen, and that's when like we have done that one. So the phone itself is a service provider for me. So I had a web server. I also had a web service provider. Basically, it could support like SOAP based and REST based services. You know what were the capabilities of a smartphone at that particular time? You know how much, what is the RAM of this one? Huh? 64 GB. Okay. I mean, and it is a quad core machine easily. Now giving those numbers, what could be the RAM of the Sony Ericsson P800 phone which you are seeing there, which is acting as a provider there? What could be the RAM approximately? Huh? 200 MB. Okay. Any other wild guesses? Huh? Actually, this is an interesting pattern. If you hear from me, I can't hear from you. Okay. So all I can hear is 256. If you want to, you can come front. Okay. So there is no problem. But anyhow, settle down. Doesn't matter. Okay. Right. So that's fine. So people are conversing around 256 bytes. No, 256 MB, isn't it? It was 12 megabytes. 12 megabytes, 2 megabytes, including the space for deploying the applications as well. Even with such resources, you can make it as a service provider. So today's things are a lot more capable, isn't it? So there is no problem at all. So you can think of it as a service provider. Now the interesting thing is, if it is a service provider, you can actually collect the sensor information on the phone and let the phone basically provide all this information to upper layers, isn't it? That's what is basically possible there. So the phone itself is now acting as a gateway. But great, if the phone acts as a gateway, how do you connect with the upper layers? Because cloud, you need to contact somehow, isn't it? Sensor data you collected at the phone with direct sensors or with the connected sensor. Now how do you basically upload the information to the cloud? You need some sort of interaction between this sort of phone layer and the cloud layer. That actually has basically got us into a new domain of research, mobile cloud computing research. So this was our main research for about some 4 or 5 years. Okay, sometime around 2012 to 2016-18, during that time. Of course, if you want to invoke the cloud services from your mobile phone, you need to have different protocols, or you need to have different access mechanisms. In terms of research, there are two different solutions are possible. One is task delegation approach, code offloading approach. The task delegation approach basically follows the standard service oriented architectures models using a middleware or something. But higher layers, code offloading, basically you have to profile your application, find out like which is a heaviest process, and you have to offload to a much powerful surrogate machine. So something like face recognition, if I want to do it on my mobile phone, it's better to offload it to a much powerful surrogate machine. And that is basically about code offloading, and that is what the intersection between mobiles and the cloud computing, mobile cloud computing. Then the upper cloud computing layer, probably you already know, but also like in the morning session, like he already mentioned what is cloud computing and so on. But at the end of the day, like you are collecting a lot of sensor information, you have to process it. I said like billions of devices getting connected. So the amount of data you are processing is in the order of zettabytes, 10 to the power of 21 bytes. How do you deal with it? So you need to have huge processing capabilities. You need to have parallel processing capabilities. You need to have distributed processing. Okay. So all these features are to be there. And of course, like another very interesting thing is like IoT data mostly deals with not just big data, but big streaming data. So the streaming data is coming. So when the sensor information is basically coming, okay, so it has to process it then. If I have given you the earlier example, isn't it? It has to process when the sensor information is there based on the CO2 level, it has to open the door. It is not like it has calculated the time now and once all of us are gone out, then it is opening the door. Okay, that is useless thing, isn't it? You don't want to have such a thing like that. So it is like a real-time streaming processing data. Do we have any solutions for that one? Yes. We do have parallel processing solutions, something like Apache Spark. Spark streaming is also there. Storm is also there. There are basically like you will actually push them into some sort of message queues, something like Apache Kafka, and you actually process it there. Good, that is about the IoT in terms of different layers is concerned. Sensors, gateways, upper level cloud layer. So basically there are several platforms which actually help you with dealing with all these things. So middlewares that enable these sort of end users to interact with everyone. Okay. There are a huge number of solutions are there. Something like ThinkSpeak, okay, ThinkWork, and Node-RED, etc. Basically, it provides you different features, something like data storage. Somehow you have to collect the information, you have to process it, you have to visualize it, you have to analyze it, and then like realize your scenario. That's about this sort of cloud computing. I mean, like Internet of cloud-centric Internet of Things, and it's basically applications and everything. During these last 2 days, you might have heard like this sort of cloud-centric IoT has several problems. One thing is it has issues with latency, okay, and also like say for example, if it is a healthcare scenario, you don't want to react after 5 minutes. You have a perfect algorithm written which actually measures your pulse, heart rate, okay, and then probably it's your BP, your oxygen saturation level during the COVID time. And if you can predict like somebody is going to get a heart attack in 5 minutes, you don't want to send all the data to a cloud and then like process it there. By the time you get the response, this person is gone, isn't it? That's a problem. You want to do the processing as low as possible in terms of this cloud-centric IoT hierarchy. So that is what is actually leading towards this sort of fog computing. Fog computing, whenever I say, people really get confused, especially with respect to terminology. I have been in this domain for the past more or less like 18 years, 15 to 18 years. So I know how things have actually evolved across this domain. People today call about edge computing, fog computing, mist computing, blah blah blah, mobile edge computing, etc. Don't get confused with all the things. It's very simple. If you can process it at the edge device, do it there. So it is called as edge computing. If you can't do it, offload it to nearest possible resource which is coming in your access. If you have a laptop is there, you want to take care of that one, take the help of laptop. People called it as cloudlets, if you have heard about it. Some people called it as edge computing as well, that one, if you offload the task to the laptop. But the interesting thing is, mobile, telecommunication technologies also had studied this offloading technology. The telecommunication guys also called it as mobile edge computing if you are trying to offload any task from your mobile to the resources provided by the telecommunication provider. So something like at your base station, it will have the additional infrastructure, you can process that. That is called mobile edge computing. So then this edge computing, mobile edge computing, people got confused, okay, you don't want to have the same name everywhere, isn't it? So those telecommunication people started talking about multi-access edge computing, okay, and the edge computing and mobile edge computing and cloud computing, cloudlets stayed the same in terms of the terminology. In the meanwhile, in 2012, Cisco basically started talking about this fog computing. What they said is like, your switches and routers are also free most of the time, you can also offload it there. If you are offloading to your network switches and routers, then it is fog computing. So basically what I am saying is, don't worry about the terminology. If you can process it at the edge device, do it there, it is edge computing. If not, offload to whatever computational resource which is actually accessible for you. give whatever the terminology, but it is in close proximity for you, so that you are reducing the latency. But if you want to go up, where like you have access to virtually infinite amount of resources, then go towards the cloud computing. So that's how like this sort of differentiation across the layer basically comes. Lot of interesting fog applications are possible. We have heard about a lot of things. I mean, I will pull out something, especially in Europe and then like Japan, they were actually using it for different smart games, okay. So interactive games. That's a game which is played by some people. I mean, friends are there, they can be anywhere across the globe connected by the internet. People, they will have a circle, virtual circle on the screen like they are seeing, there is an object in the center. Whoever is actually concentrating more is trying to pull that ball towards them. So it is like magicians, okay. So everybody is trying to pull their ball towards them. Whoever could pull the ball maximum, he wins. So that's the idea. How they were doing it? They have that sort of that band you see around the head, that is called electroencephalogram. So these bands were connected, which actually can predict like what is the brain's electrical stimulation, how much it is stimulated. You can actually get that information. There are sensors using which you can actually predict it, and whoever has this sort of modes activity is happening, okay, most agile sort of brain, he is the one who is pulling that ball near them. So that is a perfect fog based application. You have the electroencephalogram, you have a desktop which is there, which is basically getting the sensor information, processing it. It is not sending all the data to a central game server, only the process data it is sending. It is sending some control signal, let the ball move nearest to him. So that's the basic idea, one of the fog applications. Of course, the same hierarchy. So the fog computing, the gateway devices, edge devices, gateway devices, fog nodes go to the cloud. So as I am saying, in terms of data analytics, do it at the edge nodes, if not at the gateways, if not at the fog nodes, if not, go to the cloud. The interesting thing is you cannot eliminate any of these sort of movement. Now let us try to look at what is the research which is happening. These are all basics, you can actually get them anywhere. What were our contributions? What our lab was doing, okay. So look at these things. We have been working with in terms of fog based execution frameworks, fog application placement, mobility of the fog nodes. What are these things I will tell, okay, and dynamic deployment and federated learning. Great. Until now everywhere you have seen is like you have some sensor data which you collect at the gateways or the fog nodes, you process it there or you process it at the cloud. So what you are doing, you are collecting the data and you are processing on a single node. If you are processing on a single node, you cannot do much data analytics on it, but rather like if there are 10 fog nodes in this room, can you use resources of them collectively and do some sort of distributed processing? Is it possible? Yes, it is possible. We studied several frameworks and we used actor programming model, which is a distributed processing model, and we used this actor as the tool and we performed that one, a distributed data processing. Not just that one, we extended it to be also able to do some sort of neural networks training as well, okay, and that framework we called as Contour. So I am giving you several pointers, whatever you are interested in you can later check them. And another thing, so this is mostly this fog computing, you are dealing with scenarios which are event driven. You have certain sensor information, then you are taking care of an event. You have some picture analyzed, say for example if there is a camera application which is trying to detect some animals, okay, in a particular place, something like a peacock has come and so, I will talk about one of the scenarios later. So then only you want to deal with it. So for event driven processing in cloud computing domain, one very good application is there, solution is there, which is serverless computing. So serverless computing, using the serverless computing you already heard about it. So basically it is a function as services, you just call a function, you get the result. Now the interesting thing is when my sensor data is actually moving from edge devices to the gateways to the middlewares and so, every intermediate task which I am processing can be a serverless function, and we have frameworks to support that one as well. Another major research challenge, I mean like people who ever wants to do research, okay, and really want to contribute something, okay, then this is again a major challenge. You said like, okay, fog computing is there, fog nodes are there, you want to execute it there, but if I give you four fog nodes, all 4 of them are accessible, on which of the node you will execute the task? Fog placement strategy itself is a huge challenge. So people looked at different quality of service aspects, so reducing the latency, saving the energy, etc. And people also looked at several quality of experience aspects. There is a difference, subtle difference between quality of service and quality of experience. So how many of you are interested in movies? So others never watch movies? How many of you are, I mean, come on, this is a too simple question. How many of you are interested in movies? Okay, great. Okay, good. And how many of you watch movies on your laptops? Okay. How many of you watch pirated movies? Pirated. Oh, still. Come on, at least at a conference you should not be saying it, okay? Even if you do it. Still some hands are rising, okay? Right. But the point is, say for example, now the people who have raised their who watch pirated movies, just can you please raise your hand? At what quality you are seeing those movies? Huh? At what quality? Something camera quality, isn't it? So that means you are also satisfied with something of really awkward quality, okay, very bad movie, isn't it? That is your expectation. Okay? That is your quality of experience and quality of expectations. Great. But somebody, say for example like me, I don't watch, generally like I watch very less movies, okay. Even if I really have to watch a movie, I will go to a theatre and then like try to watch the highest quality. So that means like my quality of experience is a little bit higher. See, then if for example like both of us are seeing a movie on a laptop, the internet has to give me highest amount of network facility. Whereas for you, you are satisfied with your quality of experience. That is the difference between quality of service and quality of experience. And you can actually use and you can actually have your placement strategies based on that quality of experience, like that one. You can design an application like that. So all these strategies can be designed like, okay, as multi-objective optimization problems. But generally these are NP hard, and then like you need some sort of heuristics and meta heuristics for that. We basically studied several of them. So that's about the scheduling strategies. But then like all these applications, IoT applications, we tend to design them one after the other, and everything is independent of its own. But then there are several ways of designing a proper IoT application using certain standards, something like business process management. You can design a complete application using that one. Okay. So if you want to design as a BPM, and if you also want to consider, say for example, mobility of the people, we have our own simulator, which is called step 1 simulator, using which like you can actually say for example here there are 2 bus routes, again in terms of Estonian context. So that means like there is a lot of snow around. So that means like there are cameras on the buses which are actually collecting, like once they are moving in the streets, they will actually try to take the videos, and those videos are actually transferred to the bus stations. Bus stations have the fog servers. There it is offloaded, and then like it will try to find like which parts of the street are not so good. So that like, I mean like whenever like there is lot of ice on the roads become slippery. To reduce the slipperiness, you basically throw salt. It will basically tell the city government to basically put some salt in that particular street. So such things you can actually design that. So these are the tools which are developed from our lab. Great. Satish, you are just talking only about Estonia and then like what you have done in Estonia. You came back to India 3 years, what you have done here, isn't it? Of course 2 years is gone for COVID, but still we are doing something. We already have got enough projects, both from DST and also from SEB. SEB is Scientific Research Engineering Board. This is a project from that one. So this is a 25 lakhs project, okay. See, earlier I was talking about 50 crore projects from my lab, now I am talking about 25 lakhs, okay. This is the government money, more or less. One major challenge in terms of fog computing is, people talk about a lot of fog applications, but how many fog applications you see around? It's a little bit difficult, isn't it? There is a deployment challenge. It's very tough for you to deploy any application in terms of fog infrastructure is concerned. The main reasons are like platform independence. Okay, it is not there, resource constraints on the device. To address these things, we develop this sort of fog depth framework. The idea is we take care of platform independence using virtualization technology. Okay, so we heard about it earlier. Interoperability, we work with container orchestration, and portability, we looked at standardization. There are standards something like Tosca, topology and orchestration specification for cloud applications, which we try to extend it for fog devices as well, and we develop this fog depth framework, using which if you give me fog devices, any service I can deploy from my laptop directly from here. So it is called dynamic deployment. The world is moving towards DevOps. How many of you have heard about DevOps? Okay, great. So infrastructure as code and DevOps, these are the things which are to be used in terms of different applications. Then great, that is one project. Okay, another thing, look for it. Okay, so next 4 or 5 years, you will be seeing a lot of contributions in terms of federated learning. So until now we are talking about learning at a very superficial level. But what you can do is like each of these devices can learn bits and pieces, and you can have intermediate models. You can send them to a central server. You can basically aggregate them. The updated model you can send back in the next iteration. We have frameworks to support this sort of federated learning, both synchronous and asynchronous. I am giving you a lot of introduction. Okay. If you are specifically interested, you can actually check our contributions, or like you can basically talk to me, you can approach me anytime, even today or even after the talk or any day. This is again another very interesting thing. So we have another project which is from DST. University of Hyderabad has 2000 acres of land. So we have a lot of wild animals inside. But then in recent years, a lot of poaching activities are happening. How to prevent poaching? Then we jumped in and said like, great, we will deploy some sort of fog based solution and we will try to prevent poaching. But how do we do it? Then basically like the government released some money, which is 50 lakhs. Using 50 lakhs, I can have only 3 or 4 deployments, not across these 2000 acres. I need to have some sort of analytics. I need to find like which are the prominent areas of poaching activities using some sort of data analytics, and that's what we have done. Currently we are in the process of deploying it. So ultimately we will try to at least save, we will be able to save some animals in University of Hyderabad's campus. Great. Another very interesting thing, a take home message for you. All of you want to do fog based research, okay, but where to start? What is the current state of the art? Recently, like I have produced, okay, I have summarized like a decade of research in fog computing, relevance, challenges and future research directions. So basically like there is also a paper already in IC3, it is currently under review at a journal, which actually have identified like different challenges of fog in terms of fog framework, simulation, resource usage, application deployment, fog economics, literally around fog based horizon. I try to summarize all the research and put it together at one place. You can go to archive, you can download the paper. As usual, all our work has, as of now, has been open source. It's freely available. Okay, that's the motto of European Commission projects which we used to get. So get that information and read it. And there I also have mentioned some of the futuristic research challenges, not just future research challenges. So you can address any of those things. So coming to the end, excuse me. So we looked at cloud-centric Internet of Things. I discussed about several case studies from Tartu's perspective. Okay, and we looked at fog and edge computing, and then like research challenges in fog and edge computing, and then like what are the current projects which are running on at University of Hyderabad. Thank you very much for your attention. These are some of our funders, more or less, and we also have a book written together with Professor Rajkumar Bhaiya. Thank you. If you have any questions, I am open. Either now, later, anytime. Yeah, please. Yep. Yeah, okay.
And whereas the cloud computing is centralized architecture. So what are the advantages over centralized and decentralized architecture? Why we should go for fog computing?
Okay. Great. So the question is, just to repeat for the people who have not heard about it, cloud uses a centralized architecture and fog uses a decentralized architecture. Okay. And why should we go for a decentralized architecture when cloud is providing me everything, isn't it? It's promising me virtually infinite amount of resources. But the idea of fog computing itself is like having this sort of intermediate processing while the data is actually moving. You have to think about the data in terms of a pipeline. So the sensor data is generated at the sensors, it is going to the gateways, then it is processed at the fog node, next at the next fog node. Only at the end, like, it will basically go. Something like some filtering happens. Say for example, you are processing a video. You don't want to send all the video stream up, isn't it? You will be basically processing it somewhere at the gateway and seeing like only when there is a picture there, an animal moving there. When a peacock has come into my picture, then only like I will take that snapshot, okay, that frame, and that frame like I am sending it up. So always whenever you are thinking in terms of real time applications, it will never be a centralized processing, but always a distributed processing. So that is why you need to use it for computing. Thank you.
What about the security aspect? Which one is more secure?
Okay. So the next question is a question which you cannot avoid, especially with distributed computing, the security. So the question which he is putting is, which of them is more secure? It depends on the scenario. Okay, it always depends on the scenario. And of course, like I gave you that fog based, like the survey paper, isn't it? There is a specific section like which I have completely written about security aspects. See, the interesting thing is, generally we think like the public key, cryptographic things can be directly used with cloud. That's great. But with fog computing, anything above the gateway layers, we can still use this sort of cryptography and encryption. But what happened to the below the layers, below the gateway and then so and so? Because the communication is really very little possible communication, or else like you will drain the batteries. At the same time, the processing is also very little, so that you cannot do encryption. So there are several layers of security you have to think about now. It is not a single layered security, end-to-end security is not possible, but then layered based security is the critical solution for that one. Okay, so you have to think in that sense. Okay, so it always depends on the case by case. Thank you. Anything else?
If our students, if they want to take up something like cloud computing as their career or something, can you just give some suggestions regarding that? Or any simulation tools so that they can explore themselves?
That's actually okay. So I got one very interesting question. So if you are looking at cloud computing and if you want to pursue cloud computing as a career, where you should be looking at? I showed you this for fog computing, isn't it? So fog computing, we literally summarized everything, and I said like there is something for the fog computing. Now I will give you something for the cloud computing as well. So some years ago, few years ago, I co-led the development of cloud computing manifesto. Professor Raj and myself, we have actually co-led this development. We actually have collected people from across the globe, 25 different experts who are addressing different challenges of cloud computing. Okay, and then like I co-led this development. Okay, and then like people were addressing different challenges. This is called Cloud Computing Manifesto. Research directions for the next decade. And again, you see some similarity between the figure. Now you know like who drew the figure. Okay. So these are the challenges which fog computing, which cloud computing is addressing. That was published in 2019. Our prediction is like it will have enough research challenges to address until 2019. If people are interested in that in the cloud computing domain, go to the Cloud Manifesto. If people are interested in fog computing, come to the to the other, a decade of research in fog computing, okay, relevance and future research directions, challenges and future research directions. Thank you. So both the things, both cloud computing and fog computing, I am giving you concrete research ideas which you can pursue, at least for the next decade. Follow the paths, okay, or ignore. Yeah, please. Yeah, please.
How can we use IoT data analysis to build any project?
You can come closer, okay? How?
So how can we use IoT data analytics to build any project?
Okay, right. So the question is, how do you use IoT plus data analytics to realize a project, isn't it? Earlier, I talked about this one here. See, the point is, once again I basically come back to the pipelines. The data analytics for me is not like everything basically goes to a single place and then like you process it. Those things are outdated, there is nothing novel there. Okay, you basically collect the data and process it, you show me another application, no more it excites me. Okay, but the interesting thing is, the data analytics task itself can be designed as a pipeline. Collect the data from the sensor and you have fog nodes, 4 of them, you want to do some sort of distributed data analytics on that. Use my earlier solution which is like this Contour framework. Use this Contour framework and do that processing. But the thing is, like, the result of the processing, if you want to send it up, you have to design a pipeline. How you design a pipeline is, you will actually use Apache NiFi pipelines. Using, I mean, like, in terms of serverless data pipelines, we have publications where there are multiple ways we have realized it, using MQTT, using NiFi and so and so. There is also a publication for it. If you are interested, you can send me a mail, I can give you that one. But for one solution, you can use Apache NiFi, collect the sensor data, do the processing, distributed processing on the fog nodes, get the results, using the pipeline, using the NiFi pipeline, go to the next higher layer, do some more analytics. Okay, over the year, like, collect all these results, intermediate results, and put them in a server on the cloud, and you do real distributed data analytics using Apache Spark or Apache Storm or like Apache Hadoop, okay, etc. Real distributed data analytics. In that sense, like, what you are doing is, you are integrating real data analytics and data movement along the pipelines into an IoT application to explore. Thank you. Yep.
I saw in your PPT that features of IoT.
Huh?
I saw in PPT features of IoT.
Okay.
That data storage, data visualization. Sir, can you please elaborate that how we will do with the help of IoT?
So basically, the question is about, there are different features which were shown, not with respect to IoT. These features were actually shown with respect to IoT platforms. I think this is where it is. Okay, this is where, like, data storage and those things. Yes. So basic interesting thing is, why I showed that one is, generally if you have to design your IoT application, what you will do? You will have the sensors, you will connect it with a microprocessor, you will basically try to collect the data, you will put it into a file system, you basically will try to send the file to somewhere else, you process it, you visualize it yourself and you demonstrate it. The interesting thing is, like, there are several IoT platforms which does all these things for you as part of the platform. So something like, say for example, the example which I have given is like this ThingSpeak. Using the ThingSpeak, you can actually design an application. So that means, like, you can connect the sensors to ThingSpeak. The ThingSpeak is the one which is actually collecting all the information. Using ThingSpeak tools, you can actually have a analytics and then, like, visualization of the data. Using the ThingSpeak, you can do it. I was generalizing similar to ThinkSpeak. There are other things like Cumulosity, which does the same thing. ThinkWorks also does the same thing. Node-RED also does the same thing. So I generalize these features, what these IoT platforms are actually doing it for you. If you are in the process of building an IoT platform, you have to consider all these features. Okay?
Sir, I have one more question, sir.
Yeah, feel free.
Sir, can you please suggest best platform to learn IoT so that we can execute that in a real-time project? Is there, if you have ideas, sir?
I mean, I gave you already the example. Use the ThinkSpeak. In Indian context, use ThinkSpeak. And then like use the Raspberry Pi and get the sensors and then like, I am loud enough, isn't it? Is the last bench can't hear me? I think you can hear me easily. Okay. Yeah. Any other question?
Sir,
Yeah, please.
sir, like after the cleaning of data, sir,
Uh-huh.
taking some insights from data,
Mhm.
data set. Sir, my question is that how to utilize that clean data or structured data with respect to IoT platform. Sir, once we have cleaned our unstructured data,
Mhm.
we converted that into structured data, right?
Mhm.
There are so many software and
Yeah, okay.
that I understood, sir. After that, sir, how we can utilize IoT platform?
Okay.
That is my question.
Okay, right. Give me the mic now. It's a little bit of explanation. Probably you have to hear. How is this one? Okay. It's audible? It's audible. Okay, great. So what you said is like you basically collected all the data and then like you basically collected it everything at the node and how I can use it in an IoT application. Yesterday I was talking about agricultural sensor, smart agriculture. Let's consider the same case. Okay, if I am far from that one, I think it is better, or else it is making noise. So great, let us think about this sort of smart agricultural scenario. You collected the sensor information. What is the sensor information you are collecting? You deployed some sort of moisture sensor. Not audible? There, better? Okay. So great. The question is, he collected the data, he filtered it, he want to use it in an application. How I can integrate? Isn't it? That was his question. See the thing. I am giving you the same example which I have talked about. There is smart agriculture. There are sensors which are actually deployed, which is actually measuring the moisture level, CO2 level, humidity level, and it is also getting the weather information from somewhere else, which can predict like whether it will rain tomorrow or day after tomorrow. And then like now you know the moisture, and then like for some crops like you have to put water, and for some crops you don't have to put water. You have decided, and then they are in the field. You collected all the sensor information. You pushed it up using some platform. You sent it up. Great. You cleaned it. You stored it. Now you have to do analytics on top of it. The analytics is, so it is like any traditional data analytics in that solution. Say for example, if I want to do some sort of distributed processing on it, then I will use Hadoop MapReduce. If I want to have a faster analytics, I will do Spark based in-memory processing, Apache Spark based in-memory processing. And assume like say for example, I collected all this information from different fields in a village. That is big enough data for me to do some sort of processing, a gigabyte of data at say for example any hour. Okay, I don't want to do it for every second, isn't it? In this scenario, in the scenario which I am discussing, I collect the data, I try to process it using this sort of distributed processing. Now I want to basically open a gate so that water basically goes. That is about the irrigation, isn't it? Say for example, to this field like allow water, for the other field like don't allow water. That sort of opening and closing of the doors is an actuation function for an IoT device, isn't it? So what you did, you collected the data, you analyzed it on some sort of processing machine, for me a cloud or something. Now you basically have decided like I need to open that particular door. So there is an activation function which is there on the IoT platform which actually can open the door for you. Integrating that sort of analytics and then like which door to open is your application, more or less. Thank you.
Thank you, sir.
Thank you. Thank you guys. Nice audience. Yeah, okay, take it.
ಹೇಳ್ತೀನಿ ತಾಳಿ.
I don't know if they have any questions. What 10 minutes? I can even take the 1 hour. If they have very interesting questions, not anything just for the sake of art. My mouse?
cluster of how IoT, cloud and edge computing all goes together. Guys, lunch will be arranged. You can have your lunch, but before leaving for lunch, please take note. 1:30 sharp again you have to assemble back here. Okay? We'll have one more session. After that, we'll have a valedictory event. 1:30. Please try to maintain the timings. Please be back at 1:30. The necessary matters will be
ಇದೆಲ್ಲಿ ಗೊತ್ತಿಲ್ಲ ಇಲ್ಲ ಇದು ಈ ತಾನೇ ಇದು
So afternoon there will be Internet of Things demonstration. So the industry experts are coming. So kindly all of you assemble back. Okay, now. So today Dr. Soumyakanti Ghoshal and Dr. Sandeep sir really made effective all over the world in different locations, different auditorium of the colleges has been projected. This particular workshop is live casted. In YouTube you can see the number of participants and where they have the location, where they have watched it. Okay. So all these things have been taken in a different direction. And now we have a different plan. This is not going to end for this. So we will be having a lot of faculty exchange, student exchange program. So just now chairman sir told to request the different angles, the different initiatives with respect to this international conference. Many plans are ahead. If you all cooperate, if you are really attentive and interested, there will be a huge international platform for you guys. Okay. So kindly utilize this opportunity. Feel free to meet the professor, take a photo and share the things for another 10 minutes from now. 12:30 you will be having lunch. 10 minutes. Feel free to take photo and interact. If anyone of you is hesitating, please go into the link and talk to the professor. The golden opportunity is going to end for another 10 minutes. Afterwards, they are flying. So you will be not having any opportunity. Okay? So that's all. The platform is open for you. Thank you for all.
Also to be have a precious presence on the stage as we will have a group snack. Shekhar sir.
what about us मैम हम लोग क्या है हम लोग के फोटो ही नहीं प्रोजेक्ट में डिस्प्ले करो नहीं ठीक है तो वाइड एंगल से वाइड एंगल
Brother, you want to go back? He's having the YouTube live. No, I want to also cover it now. One nimsham.
ಎಲ್ಲ ಕವರ್ ಆಗಲ್ಲ
ಹಾಂ ಹಿಂದಕ್ಕೆ ಹೋಗಿ ಸುತ್ತಿ ಹಿಂದಕ್ಕೆ ಹೋಗಿ ಸರ್ ನೋಡ್ತಾ ಇರಿ ಚೈತನ್ ಸರ್ ಕಿರಣ್ ಸರ್ ಚೈತನ್ ಸರ್ ಏನು ಸರ್ ಹಾಂ ಫೋಟೋಸ್ ಅಲ್ಲ ಇದನ್ನ ನಾನು ಕವರ್ ಮಾಡಲ್ಲ ನಿಮಗೆ ಬಿಡ್ಲ ಮಾಡಲ್ಲ ಒಂದಕ್ಕೆ ಸೆಟ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ ಸರ್ ಯಾಕಂದರೆ ಸ್ಟೇಜ್ ಅಗಲ ಇದೆ
दिवेश मेरा वो तुम आईडिया के साथ
मंजुला मैम ತಗೊಂಡು ಸರ್ ಹೌದೇನು ಸರ್ ನೋಡ್ಕೊಳ್ಳಿಲ್ಲ ಸರ್ ಇಲ್ಲ ಸರ್ ಇವಾಗ 130 ಮೇಲೆ ಇದೆ ಅಂತ ಮತ್ತೆ ಇಲ್ಲ ಈಗ ಎಂಡ್ ಮಾಡಿಬಿಡ್ತೀನಿ ಸರ್ ಇದೊಂದು ಶೂಟ್ ಮಾಡ್ತಾ ಇದ್ದೆ ಹುಡುಗದು ಇದು ಮುಗಿದ ತಕ್ಷಣ ಎಂಡ್ ಮಾಡಿಬಿಡ್ತೀನಿ ಓಕೆನಾ ಹಾಂ ಸರ್ ಹಾಂ ಎಡಿಟ್ ಮಾಡ್ತೀನಿ ಹಾಂ ಸರಿ ಸರ್ ನನಗೆ CC ಕ್ಯಾಮ್ರಾ ಒಂದು ಬಂದೈತೆ ಸರ್ ಅದೇ ಪ್ರಾಬ್ಲಮ್ ಆಗ್ಬಿಟ್ಟೈತೆ
Ready? One, two, three.
Oh, हम लोग मिस करने बिना जॉब सर
ಹಾಂ
Done.
ಓಕೆ ಸರ್
ಕೇಳ್ತದೆ ಆ ಕಡೆ ಹೋಗಿ ಆ ಕಡೆ ಈ ಕಡೆ ಬಂದ ಕ್ಯಾಮ್ರಾ ಇದೆ
ಜೂಮ್ ಮಾಡಿ ಎಲ್ಲ ಮುಖ ನೀಟಾಗಿ ಕಾಣ್ತೀನಿ
ಸುರೇಶ್ ನೋಡಿ ಓಕೆನಾ ಓಕೆ ನೋಡಿ